Imagine this: you're drifting in the endless void of space, nearing a black hole. The gravity around you is unimaginable, time itself begins to warp and stretch. Your watch seems to tick slower and slower, and you realize you're not just in space, you're in a strange, time-bending experiment. You're traveling through time. Welcome, space explorers. Today, we're diving into one of the most mind-bending concepts in physics: time travel through black holes. But before we get to the wild ideas of time bending, let's break down what a black hole really is. Black holes are regions of space where gravity is so intense that not even light can escape. They form when massive stars collapse in on themselves under their own gravity, leaving behind a singularity, the point of infinite density, at their core. Surrounding this singularity is the event horizon, the point of no return. But how does something so powerful affect time? And could this force open up possibilities for traveling through time itself? Let's explore. To understand time travel, we need to dive into Einstein's theory of relativity. In simple terms, relativity tells us that time and space are connected in what's called spacetime. The presence of mass, like a planet, a star, or a black hole, curves spacetime, and this curvature affects how time flows. Imagine spacetime like a stretched rubber sheet. When you place a massive object, like a ball, on the sheet, it sinks and distorts the fabric. This is similar to how planets, stars, and black holes curve spacetime. The closer you are to a massive object, the more spacetime is warped and the slower time passes. This phenomenon is known as time dilation. In simpler terms, the stronger the gravitational field you're in, the slower time moves relative to someone farther away. So, if you were near a black hole, time for you would pass much slower compared to someone far from it. Now, let's think about this. If you spent time near a black hole, you could experience time differently from the rest of the universe. You could age slowly while everyone else around you ages much faster. This is one of the first ways we might think about time travel, specifically, traveling to the future. Out the event horizon, the boundary around a black hole. Once you cross this point, there's no turning back. Not even light can escape. But what happens if you get close to it? Well, here's where the real time-bending action happens. As you approach the event horizon, time for you would seem to slow down more and more. From your perspective, everything would seem normal, but to someone watching from far away, you'd appear to freeze in time, moving slower and slower until you seem to stop entirely. If you could somehow survive that experience, you might be able to travel into the future. For you, time would pass slowly, but for the rest of the universe, centuries or millennia could pass. It's as if you're frozen in time, but actually speeding ahead into the future. So, could this actually be considered time travel to the future? Let's explore that idea. The concept of time travel to the future through a black hole is rooted in real science. If you could safely orbit a black hole, or even hover near it for a while, time for you would slow down dramatically. Let's say you spend a year near the black hole, close enough to experience intense time dilation. When you return to Earth, you might find that centuries have passed, but you've only aged a year or so. In essence, you'd have traveled to the future. Though this sounds like science fiction, it's grounded in the physics of general relativity. Time dilation near a black hole is real, though it would require a lot of resources, technology, and precision to make such a journey feasible. But what about time travel to the past? Is it possible to go backward in time using a black hole? Some scientists believe that if black holes were connected to wormholes, tunnels through space-time that link distant points in the universe, it could be possible to travel to the past. The idea is that the black hole might act as the entrance to a wormhole, and you could travel through it to another time, potentially even to the past. However, wormholes are purely theoretical right now. We've never observed one, and even if they do exist, we'd need enormous amounts of energy and technology to stabilize them. Plus, there's the problem of paradoxes. If you went back in time and changed something, it could create a paradox, like the famous grandfather paradox, where your actions could prevent your own existence.